Okay, hi everyone. Welcome to this tutorial on the basics of Python for machine learning. Thank you very much for attending, and I really hope that you find this tutorial useful. So the choice of programming language here is Python, and I know a lot of a lot of you already have heard about Python. That's why you came to this tutorial in the first place. Python is one of the most popular programming languages in the context of data science, machine learning, science in general. A lot of coding in these fields is done in Python. And there are many reasons for this actually. Python is a versatile language, it's very well supported by a global community, an increasing number of people go into Python every year, and an increasing number of features are added to Python almost every day. So a lot of features are added to Python, making it applicable to a wide range of industries. What we are concerned with here is the application of Python for the machine learning applications. For if you want to process data, you then use this data in order to perform machine learning tasks on them. The industry that's relevant to what we will be doing today is obviously data science and data engineering. If you look at job advertisements about these in these two particular industries, you will find that many of the advertisers either ask for Python programming skills or R programming skills. Like generally, being able to program is always a very good thing to have, but people who deal with data a lot, they find Python and R very useful programming languages because of how much support these languages have for data manipulation, data transformation, and data analysis. So let's just go straight into what we're doing today. So um, basic Python for machine learning we're going to be covering a few topics. Mainly, we start with just an introduction on machine learning, and also just to let you know, and to be sure to manage the expectations. I'm not teaching machine learning today. I'll just be teaching enough Python for you guys to be able to start doing machine learning. Machine learning is vast. It's a large number of tasks or subtasks within a machine learning project. And what we're doing now is the Python required to do the very first, tasks in machine learning, which is data pre-processing or data, handling data and loading data and transforming it in such a way that we can use it for machine learning. So let's just go straight into the contents of what we will do today, the topics. So first of all, I'll talk about machine learning at large, the bird's eye view on it, and then we'll talk about Google Colab. Google Colab, which is exactly what I'm showing here, is a very nice cloud-based Python interpreter and also a way to write documents and share documents related to using Python. So you'll find that we can actually this document I created, which is also shared. You can also access it. I hope so. There is text in this document, which is this text that you see, and there is also code. So we can actually write code in this document and compile the code via a Python compiler that's sitting on Google on the Google's cloud. It's a research tool available from Google, and it's free for everybody who has a Google account. Okay, so first we'll talk about and then talk about basics of Python. So we will cover a few topics related to the Python programming language and the syntax, just to be sure that we're all on the same page and we all share the same basic ingredients of Python. I don't want to assume that everybody here knows Python already. I just want to start from the very scratch, covering the very basics of Python, and then we grow our knowledge step by step. So the basics of Python, and then importing Python libraries, which is also an important Python feature. This Python feature, importing libraries, is very important when we start using Python libraries in the next sections. So After that, we're going to learn how to import and how to use the Numpy library, which is the mathematical or the number cruncher in Python, and then the Pandas library, very popular among data engineers and data scientists, a very versatile library for dealing with data. It's called Pandas. And then text manipulation in Python, which is a very important skill when you deal with text data. For example, if you're doing natural language processing or NLP. Okay, now, so what's machine learning? What do we do with machine learning? I mean, in machine learning, the task of a machine learning project is to make a machine learn something and then produce a certain output. And the output that you want from the machine is to act based on the learning, right? So, for example, like nowadays, a very important task that we would want machine learning to do, if you know a lot of diagnosis of the COVID patients depends on the CT scans. So how about this? You get a lot of CT scans for a lot of patients, and then you teach the machine which CT scan would correlate with a COVID disease and which are not. And this actually, I mean, this is actually a research topic, and a lot of people are actually doing it nowadays. So that's just an example of an image processing machine learning project. Here, the machine is being taught images, and it's being told that, hey, this image is a COVID, this image is not a COVID. So that's why I'm saying here that here a category is predicted. We're predicting a specific category. So the answer here is a yes or no. If it's, for example, images for a cervical cancer, then the answer could either be yes, there's cancer, no, there is no cancer, or the answer could be like categorization of classifications of the cancer. Um, Images. These are images. They're actually available online, and there are actually there have been competitions where people were provided with these images to be able to to produce machine learning codes that can actually predict the presence or the lack of presence of cervical cancer. So it's a also a very common application of machine learning in medical diagnosis. So these two, we're processing data, and the data here being images. What will be the temperature tomorrow? That's a numerical data, and this data is also time dependent. So that's a separate machine learning project where we're predicting numbers, and the number has a time dimension, and it has this sort of machine learning actually has a name of its own. It's called time series analysis. But for today, I just want to highlight that, okay, there are different types of data. Regardless of what machine learning is going to be done, that's something we can cover later. But for now, there are different types of data. Data could be categorical. Sorry, data could be images. Data could be text. For example, if you want to if you want to create a machine learning system that can translate text, or a phone operator that can route the phone call of a customer to the right department within the organization. This is really done actually by machine learning. Now, getting text message, another one, background. Hi, Saskia. Okay, we started the session. Are you able to hear us? Is anybody having issues with the voice? Could you join the meeting, Saskia? There's a okay. There is a button here that on the I think on the top left in Skype that says join call. Did you see that one? So you can just click it and then you can start joining the call. Or maybe I can call you. I don't know how I would do that. Could you manage to do this, Saskia? Okay. Actually, Saskia was complaining from not hearing us, and I was calling her. I was talking to her. That's so stupid. Okay, Saskia, you can press join. Join us. Can you do that? Okay, so I'll continue, and I hope Saskia can join us. Okay, so different types of machine learning projects deal with different types of data. What now? So I said there is categorical predictions. So a machine learning project can either predict a category, like whether this patient is having COVID or not, whether this uh, let's say this material, for example, has this or that property, or whether or whether tomorrow is going to have, sorry, not tomorrow, whether other types of categorical predictions. Okay, let's just stop maybe here. I'm out of ideas. Now, for numerical predictions, we can predict a large range of numbers. Let's say predicting temperature, predicting the changes in the stock market movement, or predicting like the foreign exchange prices. All of these can also be done with machine learning. Now, these are two types of machine learning tasks. There's classification tasks, in which we are predicting a category, and there is regression tasks, in which we are predicting a number or a numerical value. Saskia, were you able to join us? Okay, I hope she can. Okay. Joining. Okay, so far I've been saying that there are different types of machine learning tasks, the regression and the classification. So there's the regression problems and classification problems. That's broadly speaking what I mean, different types of machine learning tasks. Now, and there are different types of data. So a machine learning task requires data to do machine learning. So there are different types of data. You have text data. A text data is a sequence of characters or a sequence of words, right? Yes, Elif. Well, I'm sending it, putting it here in the chat right now. Okay. No worries. Okay, so different types of data. There is text data. Text here being defined as a sequence of characters, right? Or a sequence of words, sentences. A book is a piece of text or a text data. And you can do so many things with a book. If you have a book as a sequence of characters or a sequence of words, you can do natural language processing for the book, such as, for example, writing a summary of the book, extracting questions from sentences in the book. So many things can be done if you have text data. That's something that we can maybe cover at a later stage. But for now, text is a type of data. Numerical data, numbers, all sorts of numbers like temperature, cash amount, anything that is numerical, that's numerical data. Images, two-dimensional, an image is really essentially a two-dimensional numerical data. So it is not just a number. An image is is a structured set of numbers. A genome actually is a DNA sequence, which essentially is text. And one of the reasons why Python, the usage and adoption of Python was accelerated in the bioinformatics community. Bioinformatics are the people who do a lot of machine learning and a lot of processing of DNA sequences, is because Python is very good with text. And I'll show towards the end of this tutorial some examples of functions and procedures that we can use to process text in Python. Okay, so Python has evolved as one of the programming languages that has the richest set of tools for dealing with the above data types or data forms. And this tutorial, I mean, the main objective is to actually see how we can do that with these types of data. I'm afraid I won't be able to go into the images a lot today, maybe later, but today is going to be, I'll just keep it simple. We'll present the dealing with numerical data and dealing with text data. And the idea of creating structured data, the key thing about Python is that it enables you, it has a lot of support for you to create structured data. And then for those data structures, you can then apply analysis on the structures. Okay, so Google Colab, that's the platform I'll be using in this tutorial. I've been using Google Colab in previous tutorials. In fact, I've actually presented machine learning with Python in a previous tutorial, but it was a bit specialized. It was mainly machine learning for a certain application, material science, and it's available on my blog as well. Great, good to know, Sasuke. I'm happy to maybe share information about that blog, about Python for machine learning and material science, maybe towards the end of today's tutorial, but I have a lot to cover, so I'll try to go as fast/slow as possible. So the first thing is, yep, we've got here Google Colab. Google Colab enables you to actually run Python on the browser, so you can learn, and you can read and run the codes, the Python codes in this tutorial while you are sitting in the tram. Of course, not all of us are using a lot of public transportation these days because of the coronavirus pandemic, but you don't need to install. What I mean is, you don't need to install Python to go through this tutorial. All you need to do is to open Colab on your browser, to have a Google account, and then access Colab via the Google account, and then run the Python codes within the Colab. For example, you see here, this is a line of Python. Print is a function in Python that lets you print out text, and then I'm putting string hello there. Now to run it, let me just cancel this. To run this Python code, all I need to do is obviously to click on the play button. And here it is, Python running off Google Cloud. So we're basically using the Google Cloud here, free Google Cloud, to run and learn Python. Okay, so the basics of Python. So there's a lot of writing here that you can maybe read at a later stage, but for now I'm just going to go skim through it and discuss the key things. The print statement, that's the very basic line of code in Python. It's a statement that instructs Python compiler to print out something. And that something is obviously here is a string. So print like coffee, that's a string here. A string in Python must be surrounded by double quotes or single quotes, as I'll discuss more about strings later. The print statement or the print function lets you print out a string like that. We can print one string like coffee. We can actually print two strings with a comma in between. Yes, I do. And then I can go ahead and boom, play. Whether I'm saving, and you will find out that what changes here are going to be applied in your copy. We can also print numbers like that. So comma 4, let's say 4 cups, please. So this means that the person, is being asked like coffee. Yes, I do. And then asking for 4 shots or 4 cups. Okay, so run this and boom. 4 is printed out here, even though it's a number, right? But I can print it out in the print statement. Okay, so in the print statement, I can print out things and separate them with a comma. That's how the print function works in Python. Here, the comma is here. I'm showing it here as well. Let me just remove this stuff. As I said, a string is surrounded by double quotes. It can also be surrounded by single quotes. So I can put, instead of double quotes, I can put single quotes here. Okay. Now you notice that if I start with a double quote, I must end with a double quote. I should not start with a double quote and then end with a single quote, because the string didn't really end. It will keep going. So I have to, if I start with a double quote, I must end with a double quote. Okay. Strings in Python. So a string is any collection of characters, numbers, or any characters that you find on the keyboard or even away from the keyboard. any of those characters that is surrounded by either quotes, single quotes, or double quotes, like I just said. So what I'm showing here is a string value, or it's also called a string literal. I can create a string like that and then store it in a variable. There are different types of variables in Python. There are string variables like this one. There are also numbers, and there are Boolean variables. So I'm now discussing variables, and variables, that's the predominant concept in any programming language, where a variable creates data, a space for data, and then you can fill that space of data with actual data. So for example, S equals I love coffee, and here it's the I love coffee surrounded by double quotes. S here is a variable name. I love coffee is the value that will be assigned to this variable. This whole line here is called a variable assignment, or an assignment operation. So for the assignment operation, we have to use one single equal sign. So when I say S equals I love coffee, Python is going to store that I love coffee into S, so I can print it out. So print S is going to tell me, it's going to show me I love coffee, which is just the value of S. So these are types of variables. There are numbers variables, there are Boolean variables, and string variables. So that's the string variable. We can also create a numerical variable like A equals 5. So 5 here is a number. B equals 6. C equals A plus B. So the value that will be stored inside C is going to be 11. So I can go print and then C. Okay, so 11 here was printed out because that's the arithmetic operation that was performed on the variables A and B. Now, the arithmetic operations available in Python for numbers are these ones: plus, minus, multiply, divide. Percent sign is for the modulus. Slash slash is for division without the decimal. Let me just quickly show what these mean by example. So for example, I have A equals 3, B equals 5. I can then go print. Actually, I would prefer to maybe just edit this. C here, C equals A plus B. I can also do C equals B percent A. What do you expect the outcome to be? Percent here is the modulus. It gives you the remainder. So the remainder of 6 divided by 5 is 1. So C is going to be 1. That's the remainder. Whereas if I go B divide A, divide A means that 6 divided by 5 is going to give me 1 plus 1 divided by 5. So the answer is going to be 1 as well. Okay, let's say that A is equal to maybe 2. No, A is equal to 4. No, not 4. No, let's just keep this 5 and make this 23, for example. 23 divided by 5 is 4, remainder 3. So I can get the 4 value by this double slash. So 23 divided by 5, divide 5 equals 4, whereas 23 modulus 5 is going to give me the remainder of division, which is 3. So that's the role of the percent sign and of the divide in Python. These two operations. I mean, the other 4 are pretty obvious: the plus, minus, multiply, divide by these 2. And there's some text here that I wrote that explains what these are. When we're programming, we don't want just to keep adding, multiplying, and dividing. There are a couple other things that we need to do. We need to create also questions or logical expressions or comparisons. So there are a couple of comparison operators that are available in Python. If you want to compare two things or two numbers with each other, you're going to put the equal sign between them. So when I type A equal B, I'm basically asking a question: is A identical in value to B? What do you expect to be the outcome of this operation? It is the Boolean value. It's either a true or a false. And in Python, true is with a capital T, false is with a capital F. So that's A equal B. It's like a question. The answer is a Boolean, either a true or a false. A ampersand exclamation equals B means is A not equal to B? Same thing. A less than B, A greater than B, less or equal to, greater than equal to. It's really important to fully understand what these operations are because they will be fundamental to programming in Python. So for example, here's an example code. A equals 3, B equals 5. C equals A equal B, which means that C is going to be the Boolean outcome or the logical outcome of the question that says, is 3 equal 5? So what will be the value of C here? What do you think? What will be the value of C, guys? It's going to be false because obviously A is not equal to B. A is 3 and B is 5. So if I print C, I'm going to get false. Now, D is equal to A greater than B. Is A actually greater than B? That's not the case. So if I ask this question, D equals A greater than B, D is going to be false. So if I print D, I'm going to get false. Same thing for E is equal to A less or equal than B. That's actually true. 3 is either less or equal to 5. It is actually less than 5. So this means that E is going to be true. And that's why the last one here is true. So far we've been discussing different types of variables and the operations that we can do on these variables. That's not all. We still have a lot to do. So if there's anything that's not clear, I would like to, I would really welcome questions here on the chat. The reason why I'm doing these tutorials on Skype or Zoom is because it's better to be interactive so that I know if what I'm saying it makes sense or not. If you have any questions, always feel free to interrupt, and I'm gonna hear that you've left a message in the chat. I'm gonna read it. If you have any questions, and I can address it. Okay, now so far we've been dealing with single variables, like a variable A and something inside A, like a value inside A, like a number, for example. Python has what's called collection types, and these collection types enable you to place several values inside one variable. One of the collection types is called a list. So you can create a list of numbers, for example, or a list of strings. Say, for example, that's a list of numbers. See, A is equal to 4, 6, 7, 1, 0. Now, let's pay attention to the syntax. How do we create a list? A list can be created by, it's just an assignment statement, as you can see here. So A equal an assignment statement like we've seen earlier with A equals 4, A equals hello. But on the right side of the equal sign, we've got a syntax for lists. And the list syntax goes like this. It starts with a square bracket, ends with a square bracket, and the list elements are separated by a comma. Now, you can put anything you want inside the list. You can create a list of numbers like this one, a list of strings like this one, or even a list of numbers and strings like A equals 3, 0, where's my car? That's a number, and a string. Lists are pretty flexible in Python. You can also create a list of lists. Do you see here this one? A equals, open square bracket, and then a list, comma, list, comma, a list. That's basically a list of 3 lists. Each list is a list of 2 numbers. By the way, this could also be seen as a 2-dimensional array. One dimension is 3, 1, 2, 3, and the other dimension is 2, 1, 2. So you can put these numbers on a table actually. We will talk more about multidimensional lists later when we discuss Numpy. But for now, let's just keep going with lists. To access the value and change a value in a list, or an element in the list, we have to follow the bracket syntax. Let's say that we have here A equals, I want to order the $4 mocha. Now, that's a list of strings and a number. Okay, I can print out the first element in that list. To access an element in the list, I must use brackets. In Python, anywhere where we need to access an element in a collection, we always use the bracket symbol. Bracket, and then the index, and then close bracket. In Python, the first element of a list is always index 0. So when Python indexes the elements in this list, for example, it goes like 0, 1, 2, 3, 4, 5, 6, 7. So the index 5 element in this list is number 4. So the index 5 element is actually the 6th element. Well, it's like the first element, second, third, fourth, fifth, and 6th. So again, the first element in the list is going to have index 0. When I type A of 0, I'm going to get I, which is this I. Okay, so string I is the first element in the list with index 0. How about we can, change one of the elements? So we can actually assign this string here to the element index 5, right? So A of 5 equals blah, blah, blah. If I start from this list, I change the value of index 5 elements, and then I print out the resultant list. Here's what I get. Yes, you can. Instead of 4, initially I had 4, now it became yes, you can, because I assigned it a different value. So you can create lists, and then you can fill them up with whatever you want, and then you can assign them, reassign the values to whatever you want using the bracket notation on the left side of the assignment operation or the assignment operator. To check if a value exists in the list, we can use the in keyword. So if I go to in A, this is actually a Boolean expression that is going to return either a true or a false. So if we discuss this list, for example, is 2 in this list? 2 is not actually in this list. 2 is not here. So if I go 2 in A, I'm going to get false. Let me try that actually. If I go print 2 in A and then run this, false. Hold on a second, please. Okay. So 2 in A is testing the value of with the presence of the value 2 inside the list A. That's actually an operator in, and it's very important to remember how it works because we're going to use it later. So it's a logical operation that yields a logical value. So far, so good. Am I going too fast, too slow? All good? Any questions at this stage? Okay. I'm seeing that 10 of 17 people in the call. I hope that everybody is able to join our call. Okay, anyway. So checking if value exists in a list using the in keyword. Now tuples. I said that lists are collections of data, whatever data types that you want. You can change the values of the data in the list. In a tuple is exactly matches. It looks pretty much like a list. You can access the data elements in a list in a tuple the same way like you can in a list, but you cannot change anything in a tuple after you create a tuple. So let's say a tuple is pretty much like a list. It's a set of data, a set of elements. It can be numbers, strings, whatever. The difference between a tuple and a list is how you created the syntax. In a list, you use a square bracket like that, whereas, like that, a square bracket, whereas in a tuple, it's a parenthesis. That's the key syntactic difference between a tuple and a list. So you create this, for example, is a tuple of 3 numbers. If I want to change that's index 0, so this means basically I want to change 3. I want to set it to 2. If I try to do that, I'm going to get an error. The error says tuple object does not support item assignment. I cannot assign that item to anything. The tuple once created can never be changed. You can destroy a tuple, but you cannot change the tuple. Dictionaries is a more complex data structure in Python. In a dictionary, instead of just chucking in things into a list or a tuple, a dictionary has an index or a key corresponding to every value that you put. So instead of putting numbers, like the case in a list, in a dictionary, you label each number by some label, and that label is called a key in the dictionary language. So, or in the Python language. Actually, in any language, that's how people talk about dictionaries, whether it's in Python, it's in PHP, it's in JavaScript. Many other languages support that construct, and that's how they call it. They call the two things in every element in a dictionary. So that's a dictionary. For example, A has got 1, 2, 3 elements. Each element has a key and a value. The key here can be anything. Actually, you can put an apple, like a string apple. You can actually put a key being a number too. That could be a key. Or you can put melon. Or you can put, what else? True for a key. Okay. For now, I'll just leave it as apple. There are certain conditions for keys. We can discuss this later. I think I left it here somewhere. This note about keys. The keys should be of a data type that's immutable. A value can really be anything. You can put anything for a value. You can put a number, you can put a dictionary, you can put a list, you can put anything you want in the value. Okay. How do we access, for example, number 3.5? You see, print A of apple. So you use the key to access the value. That's why they call it key value or a key value pair. A dictionary matches between a key value pairs, right? And then you can access a value via its key using the bracket notation. If I want to get 3.5, I can just go A of apple or A square bracket apple. Same thing here, B is equal to A lists, B tuple, C sets. If I print B of C, it's going to give me sets. So if I run this code, I'm going to get 3.5. That's for the A of apple, and I'm going to get sets for the B of C. Okay, in Python, if you want to write a line, for example, like for example, I want to write some text into my code to explain what this is about, I can just go, this is about dictionaries. Do you notice something that I started this line with a hash? The hash helps me to write comments in Python. Hashes are, the hash is a syntax to write comments in Python. A comment is something inside your code that will be completely ignored by the compiler. So when I compile this line, this code, the compiler is going to go to this hashed line and it will completely ignore it. Hashing or the commenting is extremely useful when you want to add information about how your code runs, or if you want to do like what I'm doing here, explaining how the code works and that sort of stuff. So comments in Python, that's how you can write comments in Python, just by using the hash at the beginning. Now, time is running out. I'll just go quickly as fast as I can. Conditional statements in Python, there are, like, so far we've discussed assignment operations and different data types and operations of data types, conditional. So, and then there are more complex statements in Python. So there are conditional statements and there are loop statements. Conditional statements, that's the if statement in Python. And a conditional statement will execute a certain set of instructions or statements based on the Boolean value of a certain expression. Like here, for example, s equals Ahmed. If s of 0, which is this one, equal a, print s. So only if the first element or the first character of this string is a, print s. If it's not, then don't print anything. So if I run this actually is the case. So print s is going to print Ahmed. Okay, elif or else if is if you have other conditions. Let's say, for example, temperature equals 15. If the temperature is less than 15, print I'm wearing a jacket. Elif or else if, but it's written elif, that's the syntax. Elif temperature is less than 20, so it's basically it's less than 20 and greater than 15, print I'm wearing a jumper. Else is a syntax, or it's a keyword. It's a keyword that says that if all the others conditions are false, do this. I'm wearing a t-shirt. So let's just put some different numbers for temperature. If temperature is 15 and I run this, I'm wearing a jumper because I'm gonna get this one because it's 15. It's larger than sorry, it's equal to 15. It's not less than 15, so it's gonna match with this one. So I'm gonna get I'm wearing a jumper. If I put 30 here, this is gonna be false and this is gonna be false. So else is gonna be invoked, and I'm gonna get I'm wearing a t-shirt. So that's how the if, elif, and else work. Now loop statements, and that's when programming starts becoming actually more fun, because a loop statement is a statement that will repetitively execute a set of statements based on a condition, and that condition could be at like for the I mean there are different types of loops. There are two types of loop statements. There is the for loop and there's the while loop. In the for loop, the condition is that x belongs to a collection, whereas in the while loop, the condition for the repetition is that some Boolean expression is true. Let's just look at the for loop first. An example for the for loop is for a k in this list. Remember the in keyword in lists? Now here in the for loop, we're going to be actually using it to say for every value of k in this list, print k. So this means that the for loop is going to take the list and will assign k every element in this list. So in the first iteration of this for loop, k will be equal 1, and then it will print k. Second iteration, k will be 2, print k. Third iteration, k will be equal 3, print k. And that's why when I run these two lines of code, I get 1, 2, 3. So this for loop is repeating the execution of print k for 3 values of k from this list. In the while loop, I'm repeating the expressions or the statements based on the truth value of this Boolean expression. A is equal to 10, while A is still greater than 0, which means that while this is true, print A, and then A minus equals 1. By the way, A minus equals 1 is exactly the same as saying A equals A minus 1. Let me just put a hash here just to explain. So how will this while loop work? I start with A equals 10. As long as A is greater than 0, keep printing A, and every step reduce A by 1. So first we start with 10, 9, 8, 7 until we reach 1. Once we reach 1, A is greater than 0, that's correct. Print A, it prints 1, and then A equals A minus 1. So we get A becoming 0, right? And then while 0 is greater than 0 becomes a false value and terminates the while loop. Okay, so far I've covered some of the basic ingredients of Python, or the basic syntax in Python. Let's go now and discuss some of the Python libraries. Before we discuss libraries, let's see how we can actually import libraries. Many different Python libraries available in the world that are actually available for free online. And the way you can install a library is first you download the library, and then you import the library. So how do you import the library? You just go import. For example, if it's Numpy, which we will be discussing in a minute, we just go import Numpy. We can also import Numpy and give it an alias, so we can reference that Numpy library, that name, via its alias. And the alias here is np. So as is the keyword to use if you want to give that library an alias. So import Numpy as np. If I want to access a certain, actually you can, Colab comes ready with a number of libraries such as Numpy, whereas if you want to use a particular library that's not in Colab, here is what you can do. That's a good question, Sasky. For example, let's say that I want to install Numpy. Let's assume Numpy is not there. To do it, to install it, I would go exclamation mark pip3 install Numpy. And then run it. So pip3 is a command that installs libraries. As you can see here, it says requirement already satisfied. Let's say that now I want to install something that's not in Colab. Let's say I want to install Beautiful Soup, for example. Beautiful Soup. So Beautiful Soup is a library that enables people to scrape web pages. So I'm going to install. I'm not sure exactly what the problem is. Downloading Beautiful Soup. Yeah, it's not gonna be happy with Beautiful Soup. Maybe VS4. I'm just really making this stuff up. Oh, it's actually. Oh yeah. So it's not called Beautiful Soup. It's called BS4. Beautiful Soup. The name when I install it is BS4. So if I want to install it, I just go ahead like this: pip3 exclamation pip3 install BS4. Okay. That's how I can install libraries in Python, and then I can use them by importing them using the import keyword. Now, if I want to use a function from Numpy, which I imported here, I just go np.log. Log is the logarithm function. We'll talk about the functions available in Numpy shortly, but this is how I can invoke a function from an imported library. Okay, let's say that I want to import just one function from Numpy. I use from Numpy import sin, or the sign function, and then I can print out sign of 10 and I get that number. Okay. Okay, Numpy, what's Numpy? Keep talking about Numpy. I'm sure that a lot of you have already heard of it. Numpy is a number cruncher in Python. It's the library that can deal with numbers pretty well. Numpy is good with numbers, not just because of the functions that it has. It has a huge number of functions for numbers, statistics, and mathematics, trigonometry, calculus. I mean, a huge number of functions. Numpy also has the beautiful Numpy arrays. I've got here some explanation of what Numpy arrays are. Numpy arrays are different from lists in Python. A Python list, you can create a list and put numbers in it, but a Numpy array allows you to do vector and matrix operations on numbers. So let's say, and you cannot do this with Python lists. Let's say I want to create a Numpy array like 4, 6, 7, just in an array. So to do this, a equals np.array, and that's the syntax. If I want to determine what is the length of that array or the shape of that array, there's a shape attribute inside Numpy arrays. So if I run this code, I'm going to get 3 because it's just, it's a one-dimensional, array that has 3 elements in it. If I create a 2-dimensional array and then I ask for the shape, I get 2, 3. That's a 2-dimensional array with 2 by 3. It's almost 2 rows by 3 columns. Okay, I can access the first element or the first row in this matrix by a of 0, just like I did in lists. The bracket notation to access elements in the list. Same thing goes with accessing elements in an NP or a Numpy array. Now, the cool stuff about Numpy arrays are the array operations. So I can create this array, for example, and then I can multiply the array element-wise or element by element by number 4. So I create a equals np array. That's the matrix I have, and then a times 4 is going to multiply 4 by each number or each element in the matrix. I can also multiply Numpy arrays element-wise. So I have here two Numpy arrays, and then print a times b is going to print the first time the first, second times second, third times third. Not just multiplying, I can also do the same with division, addition, and subtraction. So here I'm printing out the multiplication and all the 4 arithmetic operations on the Numpy arrays. Now, what about matrix multiplications? We have to use a dot function in Numpy. And how the dot function works, let's say that I have That's a 2 by 3 matrix, and that's a 3 by 2 matrix. So I can actually multiply those metrics by matrix multiplication. How to use a dot function, there are two different ways to do it, and they give the same result. Either I go a dot and then open parenthesis b, or I go np dot and then a comma b, and they give me the same exact result. You see here, these are actually matrices. See, that's a matrix, 2 by 2 matrix. It's 2 by 2 because 3 by 2 times 2 by 3. No, sorry, it's 2 by 3 times 3 by 2. You get a 2 by 2 matrix. To get a peek of, a sneak peek of the wealth of mathematical functions in Python, I gave you here the links. It's pretty amazing. Let's just have a look, for example, here. That's statistics functions, a huge lot of them, and like histogram, correlation, variance, standard deviation, mean. It does support a lot of statistics, in particular descriptive statistics. So if you want to see the mathematical functions that are in Numpy, actually a lot of them as well. Okay, now let's say, for example, that you want to do some descriptive statistics of a set of numbers. So I have an Numpy array of these numbers here, and you want to calculate the sum, mean, or the average, maximum, minimum, standard deviation, and variance. I mean, there's a function for each one of those in Numpy, and I'm just showing you here a printout of what you can do. The code for how to actually present or calculate these descriptive statistics quantities. And by the way, that's really important for the data processing that you would do for any regression or actually any machine learning task. When you're looking or when you want to visualize and understand your data, you need a bit of statistics to understand the distribution of your data, if there are any outliers and all that stuff. So these are ingredients of what you can do for these tasks. So that has been Numpy, just a quick overview, and there's a huge amount of resources, learning resources on Numpy on the internet. As we're approaching almost 1 hour now, I'll just go quickly also into Pandas. That's the data workhorse in Python, or the data engineering platform. People who deal with the data transformation, like in Python, really like to use Pandas. Anyone who's dealing with data science also would definitely be using Pandas at some point, and it's supported by any of the popular machine learning platforms such as scikit-learn, PyTorch, TensorFlow, Google's TensorFlow. All of these you can use Pandas for those, to represent data to these to the models in these platforms. So how does Pandas work? Like in Numpy, we present data in terms of the Numpy array. In Pandas, we present data as a data frame. Now, a data frame is more like a table, like an Excel sheet. It has an index or a primary key on the far left side, like the column A. It's like the index, and it has field titles and has fields, right? So let's say, for example, we have a table of 3 columns, of 2 columns, fruit and price, and for every fruit there is a price. So apple is for $4, banana for 3.5, pear is for 2. I think that's an updated set of numbers from the grocer next door. So fruit and price. So if you want to create a data frame that represents this tabular data, this is the syntax: p equals pd dot data frame. You see, I imported pandas, and then p equals pd dot data frame, and then open curly brackets, and then do add the data exactly like we did in dictionaries above. Curly brackets, and then there's a key. Every field name is a key, and then the values inside that field go as a value, as a list of values corresponding to that key. And when we do this, print out that data frame, and we get this beautiful table here: fruit, apple, banana, pear, price for 3.5 and 2. Now, if you want, for example, to grab the row number 1, which is this one, we use the LOC function. So p.loc of 1, which corresponds to that index, gives you this outcome here. Fruit is banana, price is 3.5. We can also grab or search or query the pandas data frame for bananas, for any banana records. So to do this, we use the LOC again, but we have to pass a Boolean expression inside LOC. So p.loc or LOC, p.fruit, because that's the column we're searching with, equal banana. So whenever p.fruit is equal to banana, please give me that row. And we only have one row, which is that one. Let's say that we want to find all the rows that have a price larger than 2. Same thing here. P.price larger than 2 is going to give us those 2 rows. Apple, which is 4, banana, which is 3.5. One of the really cool things about Pandas is how it can save and load CSV files. If you have a CSV data file, the quickest thing to make it ready for machine learning is to use Pandas, and in particular to use the CSV functions in Pandas. Let's say, for example, that you want to save this data frame, the fruits data frame, into a CSV file. You just go p.to.csv. You run this, and it's going to save it as a CSV file, fruits.csv. Let's now read it. So I'm going to go run this. Q equals read CSV. It's going to read it. It will make sure that the index column is the first column, and the header or the field names are in the first row. And then I actually reproduce the data frame that I created above. So to CSV, read CSV, I would suggest that you read about them and see how they work. They just make life way easier when you're dealing with CSV files. Okay, so far I've been talking about structured data. Now, when you do a natural language processing in Python or anything that involves text, you want to deal with the text manipulation functionalities or functions in Python. We don't have a lot of time to go through these, so maybe I'll keep them for a later tutorial. But for now, just a quick overview of some of the functions that we have in Python. If you have a string s, upper is going to turn all the case into uppercase, lowercase. Strip is going to remove all the trailing spaces from the string. Split, which is really an important one, splits a string of words into a list of words. So for example, if I have this is some text, split is going to present this as some text into, lots of trailing spaces. We'll convert it into a list of words. There's a comment. No worries. And yeah, and then a couple of more functions here, like for example, replaces any occurrence of A with B in string S. Now, the way join works is it converts a list into a string. Let's say, for example, you have list ABC is a string dot join, and you have this list. What it does is it will take X, put it before ABC, and then Y, ABC, and then Z. So when this line runs, this join operation, the ABC is going to be surrounded with a X, Y, and Z in this way. And this is one of the very important functions. In natural language processing, people use a lot of join and a lot of split. Obviously, strip. Of course, when you're doing natural language processing, one of the first pre-processing things you do with text is to present everything into lowercase. And maybe later, in a later tutorial, I will show some of my own natural language processing stuff that I do, and some of the steps and some of the standard processing that people do using Python to pre-process a text to make it ready for digitization and for numerical representation before it can become viable for machine learning. Now that takes us to the end of this tutorial. I really hope, even though I know that I've compressed a lot of material and I went a bit above the 1 hour that I originally planned, but I really hope that it was useful to everyone. If you have any questions, let's just take a few minutes to answer them, and that will be it. I will announce about a future tutorial on a more specialized topic using Python for machine learning through my Twitter. So thank you for your attention and questions, if anyone has any questions. You can also, I think, ask by voice if you want. That's all right, Saskia. Happy that you found it useful. No worries. Okay, maybe we'll call it a day then. And okay, I'll just stop recording.